Shoot, man. Okay. Uh, so we're gonna start out by building a convoy freighter that carries two different ships and multiple cargo bays. And the cargo bays are just basically to hold like a Dragon capsule, right? And then those you can hold like maybe 4 of them or whatever. So we determined how much that would make us per round trip to the moon. Now this one just orbits the Earth and the moon. So it creates a combined orbit and goes around the Earth and the moon over and over again, delivering supplies to the moon and then back to the Earth. Then again, on Earth orbit, we want a custom station with rules, like mass restrictions on what can enter Earth orbit so that nothing could fall down and destroy the planet, because we're going to be building large ships on the moon. And the military is going to want a orbital aircraft carrier with fall away like drop shells, so the aircraft fall into the atmosphere, the shell falls away, and then the plane starts flying. And they can deliver those wherever they want to at any time, which is just awesome. So that's Earth orbit, and then we get to the moon, and we're going to have communications buildings instead of satellites like we have now. These are going to be aimed, because the moon's face always faces the Earth, so it's awesome to put buildings there to replace satellites. And then this clears up the Earth orbit. And then, man, there was so much stuff for the moon. But it's basically going to be a concrete construction yard that builds ships out of concrete, and repairs ships. And then, colonization. Let's see, what else can you have? Glass manufacturing, because of the silicate. And then, somebody's going to wind up mining deuterium, but that's not really something that seems like it's going to be a very high volume company. Space concrete is going to be way more profitable. So you got the transportation, and then you got basically the space concrete is what the moon's main purpose is for. But secondary, you have glass manufacturing. You're going to obviously start doing metallurgy and mining, and then have a city grow up in that location. And then it's going to become your inner space harbor, so that you can use it, because it's so much easier to lift off of the moon, because it's only got like 1/10 of the gravity or 1/6 of the gravity or whatever that the Earth does. So then we go on to Venus, and we develop that orbital compression system that pumps the gases out of a gas planet and compresses them in orbit, bottles them, and then ships them to the fuel stations so that people can just use the fuel. Then we could also use the suborbital flotillas and float around in the upper atmosphere of Venus, because it's also got oxygen, and we could use those to mine oxygen directly, or we could use UV light to destroy the electron bonds that are in the CO2 and split them up into individual oxygen molecules that then combine in the cooling chamber to do oxygen generation with either CO2 from orbit or oxygen from suborbital, or like say your oxygen CO2 filtration device on your ships in your stations. And we go on to Mars. There's not really much to do on Mars. You have Deimos and Phobos, and you can do concrete there. You know, I mean, you could set up like a station where you're gonna stay on, you know, out of the gravity, because once you could fly, you don't really want to go back into the hole where you can't fly again. So, I mean, I see like maybe some stations on, or maybe turning Deimos or Phobos into like a giant type spacecraft that just is going to orbit frickin' Mars, you know. Until we can come up with a better way to enter and exit gravity, I don't really see a good reason for landing on Mars, because it's just a hassle. And like, our whole object is to get off of gravity, and like say, because it just gives us such a greater advantage. So then we go on to Jupiter, and we take the Jupiter and Saturn groups, and we go to all of the ocean moons there. We fill them with as much aquatic life, as biodiverse as we can. You know, we provide heat and light and all the things, food, all the things that those animals need to get a foothold. And then we try to colonize as many ocean moons as we can with life, because later on that could feed billions of people, you know, and it's just better to have life on more than one world. Then we can also mine the ice water mines for survival purposes, for use in like steam engines, you know, and various things like that. And then the rocky moons that are around there, they're mostly ice water moons, but the rocky ones that are around there, then we can also set up shipyards, concrete construction facilities, copy what we did on the moon. Then we get out to Uranus and Neptune, and we they have a very similar gravity to the Earth, just hazardous atmosphere. So, I mean, but that's the same thing as no atmosphere, right? So we can land on those planets. I mean, we can mine. First of all, we can use orcs to pump the gases from the planets. But when we land on them, they have like flammable, highly flammable, like ices and stuff like that, like different various chemicals, that, and not just water ice. Even though their moons have water ice, of course we're going to do those. You know, if we can get a powerful enough, like say nuclear heater or powerful enough lighting, we're going to want to put life on their moons. But as far as the major planets go, they got like some serious, like, you know, flammability chemicals that we can use as even more powerful fuel than just compressed CO2. So those will have an orbital compression system on them, both Neptune and Uranus. And then, you know, wherever we find a rocky world, I mean, it's concrete and a shipyard, but those aren't really going to be as necessary as, like, say, as many ice mines as possible, because we want as much water as we can get that's in space already. We want as much of anything that we can get that's in space and out of gravity already. So we concentrate on the moons. We concentrate on the methods and the resources that we need for survival, and we just get that stuff going, you know. And so, I mean, as long as it's out of gravity, we fly to it, we land on it, we touch it, you know, and we fly away with big ships or whatever, you know. Then we can get out to Pluto, you know, and that looks like a rocky world. I mean, I don't know much about Pluto, but I suppose that could be a last center outpost, you know. And then when you have concrete production, like you're just repairing your ships with concrete or whatever. So, I mean, and of course we can mine all the rock too or whatnot. Now, that's all separate from the interstellar FTL drive, which we use to go to other stars. You know, I mean, at any point along that timeline, we're going to be able to set up, you know, but we want to be able to, we're going to be able to set up an FTL drive. But we want to be able to, like, say, have the concrete production, because we're flying a concrete ship. We want to be able to do that wherever we get to. We want to be able to get water wherever we get to. We want to be able to get compressed gas wherever we get to. So it's got to take those three things with it, along with the food, you know, and the regenerative ecosystem and all of those things. But as far as the FTL drive goes, you know, it's just a matter of adding up your speed. And I talk about that all the time in writing. You know, I don't really need to go over it right now, but we pretty much get to the end of the entire solar system, and then you can see now that we have settlements everywhere from Venus all the way out to Neptune, Uranus, maybe even Pluto. And then we just keep expanding. We go to the dwarf planets. You could even have people, I mean, of course, you know, the more population you get out there, the more and more population that you get into space, the more and more innovation and new inventions and brilliant ideas you're going to come up with. It's no longer just going to be one little think tank, one little group of people like at NASA that just this is their only job. Instead, you're going to have millions of people that live up there and work up there and understand the environment and do the things that they do every single day and come up with new innovations that nobody else ever thought of before. So you just wind up with this massive explosion of human ingenuity. And it moves outward from there. So you have all these private industries that are going to say, like, you know, all the things that we've already all come up with, mining asteroids, mining carbon, mining deuterium, you know, blah, 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 and so on. Like, that everybody's already thought about. But the things that we're looking forward to now are what our populations are going to come up with that is totally unexpected, that nobody ever heard of before. So that's pretty much where we are right now. We got to the end of all known information on the solar system and colonized everything, except we didn't really touch Mercury and we didn't really touch Mars. But I mean, so many people are working on Mars, like we don't really care. But now, like, we're at the point where we want to take our FTL drive and we want to go out. And I don't know, maybe we're like 100 years in the future now. And from the start of this video, it was like tomorrow to 100 years from now. And you're making money the whole way. Pretty much everything I listed is a profitable operation. So, the end.